All right, hello everyone. Your notes for today are going to happen right underneath your launch. So somewhere below your launch, maybe on the next page, create a space for notes. And then go ahead and pause the video to get this first example copied down. So we're going to go through this first example together. This is pretty similar to your launch question. You can see here that we're asked to evaluate a function for a given input. So in order to evaluate f of x plus h, I'm going to go ahead and identify what's inside the parentheses as my input, meaning that's what I'm going to plug in for x into the function to receive some sort of corresponding output, which is the theme for 2.1 so far. So every time I see an x, I'm going to replace that x with x plus h. So here my first x is an x squared. That's going to become x plus h squared. And then minus 2. So we're going to go a little bit further today, as you saw during the launch, and we're going to start to expand out these types of expressions. So we know that this squared here in math means that I'm multiplying x plus h times x plus h. So if I expand, this is called expanding. If I expand this out, it would look like this, and then I still have the minus 2 at the end. Okay. So what I'm going to do now is go ahead and FOIL. I'm going to distribute out this expression. So the first thing I'm going to do is multiply x times x, which is x squared. Then I'm going to go ahead and do my inside terms. So h times x would be hx. Then I'm going to go ahead and multiply my outside terms, which is going to give me another hx. And then finally, the last two terms, h times h, would be h squared minus 2. Okay, so if this step did not make any sense to you, this is called foiling or distributing out an expression. If this doesn't make any sense to you, I encourage you to actually pause this video and search for another video that will walk you through the basics of foiling or distributing, because this is going to be an important skill for class today. So next I see that I have two like terms. I have hx and hx. So I'm going to add them. So I have x squared plus 2hx plus h squared minus 2. Now I'm going to double check my final answer. I want to make sure I have no like terms that I can combine. And it looks like I don't, so that's my final answer. This is the simplest form. So our final answers today are most of the time going to be these long expressions. So I know that f of x plus h, when I evaluate it, it turns into this long expression with all these different variables. Okay, so for example 2, we're going to do a similar problem. We're actually going to use the same function. Let f of x equal x squared minus 2. And then we're going to evaluate f of 2 plus h. So what I encourage you to do is pause the video here. Try to work out example 2 on your own based on what you just saw in example 1. And then play the video again and see if you were able to do it correctly. So check your answer. Okay, so hopefully you notice the first step is going to be plugging in 2 plus h as your input. That's what's inside the parentheses. And let's zoom in here. And we're going to end up getting 2 plus h squared minus 2. I'm going to go ahead and expand 2 plus h, 2 plus h minus 2. I'm going to distribute 2 times 2 is 4, plus 2h, plus 2h, plus h squared minus 2, 4 plus 4h plus h squared minus 2. And it looks like I'm able to combine like terms because I have a 4 and a negative 2. 4 minus 2 is 2. So this is going to become 2 plus 4h plus h squared would be my final answer here. All right, so now we're going to go over a problem that's very similar to the most challenging question on your problem set. We're going to build on the same examples we just did, and we're going to make it a little bit more challenging. So for example 3, we're going to use the same function. So we're going to let f of x equal x squared minus 2. Now we're going to evaluate something a little bit more complicated. So stick with me here. We're going to evaluate f of 2 plus h. So that's similar to what we just did. But then we're going to subtract f of 2, and we're going to divide the whole thing by h. Okay, so the key for me to not getting overwhelmed by this problem is breaking it down into 3 steps, which your problem set actually does pretty nicely for you. So the first thing I'm going to do is evaluate f of 2 plus h. I'm just going to focus on this part right here and ignore the rest. So f of 2 plus h, what would that be? Well, we actually just computed it, so I'm not going to go through it again, but if you go back to example 2, f of 2 plus h for this function is 2 plus 4h plus h squared. So I'm just going to pull that information here since I already went through all the work. 2 plus 4h plus h squared. Okay. So now I'm going to pull the next kind of piece of my expression that I'm trying to evaluate, which is f of 2. And I'm only going to focus on f of 2. I'm not going to worry about putting it all together yet. So f of 2, so I'm evaluating this piece here. How am I going to evaluate that? Well, 2 is my input, so it's what I'm going to plug in for x into my function, which I'm given up here. So it's f of x equals x squared minus 2, f of 2 equals 2 squared minus 2, 4 minus 2 is 2. Okay, so my final answer here, f of 2 is equal to 2. So maybe you can see where I'm going with this. F of 2 is equal to 2. F of 2 plus h is equal to 2 plus 4h plus h. I can actually plug in these outputs. Let me go ahead and label them as outputs. So what I found was an output, what I found was an output given a certain input. I can plug these outputs into this expression I'm trying to evaluate. So I'm going to go ahead and copy down this expression I'm trying to evaluate. F of 2 plus h minus f of 2 over H. Just to keep the color coding going, and remind myself that corresponds to the pink, this corresponds to the yellow, and I'm going to replace f of 2 plus h with that, with the output that it produces. So that's going to be 2 plus 4h plus h squared. I'm going to put this in parentheses so I don't get confused. Then I'm going to subtract f of 2, which is 2. And that's all going to go over h. Okay, you might leave this as your final answer, but we can also go further and make this look nicer and more simple. So let's do it. So the first thing that you'll notice is the first 2 and the last 2. 2 minus 2 are just going to cancel out. So if I were to cancel out the 2's, it already looks a little bit nicer. It's going to be 4h plus h squared over h. Okay, I could leave that. I could also keep going. I have a common factor in the numerator. I have 2 h's here. I'm going to take out that common factor of h. I'll be left with 4 plus h in the parentheses over h. And then I have another nice thing about math, which is when you have something in the top and the bottom and it's being multiplied, you can cancel out. So these h's cancel out, and I'm left with my final answer of 4 plus h, which is a very nice and neat final answer. The key of class today is not necessarily going through this simplification process, but really I wanted you to get a taste of what it's like to evaluate a more complicated question where you have something big and meaty like this that you're trying to evaluate. Some of you might be thinking that this is really similar to average rate of change. And if you were thinking that, you're absolutely correct. This is very, very similar. This equation that we evaluated is very, very similar to average rate of change. When you get to calculus, this equation is actually one of the first things that you're going to learn, which is why I chose to do this problem with this particular equation. This equation is for something that in calculus is called instantaneous rate of change. So we'll talk more about that as the unit goes on. Not super important for class today, but it is related to average rate of change, something slightly different. All right, thank you very much for your attention during these notes. Next thing we're going to do in class is move into finishing up our problem sets and then some peer grading. All right, thank you.